So 192.168, 152.128. So yesterday we discussed about routing protocol authentication. Okay. Let me just share my screen. Please wait. So let me share my screen. Can you see all of you? Okay. So we discussed what is routing protocol authentication. I told you, I explained you. So this is your second part where we'll be practically doing EIGRP authentication, that is plain text authentication, as well as MD5 authentication. This is part of your syllabus and this is simple. Okay. So I have a setup here. You can see. Okay. So we'll just start. We'll go to Secure CRT and we will see how many routers are there. We have 1, 2, 3, 4 routers. Okay, good. So if you see my setup is like that. I can ping R2 router and the IP address is 12.1, 12.2 R2 router. So my R2 router can ping. If you see R1 is connected to R2, R1 is connected to R3. So I can say 13.3 R3. So my WAN connectivity is perfect between R1 and R2 and R1 and R3. What about R2? Can I ping 172.16.20.1? Yes. But I also have to connect R2 to R4. That is on E0 by 2. So I'll just say interface E0 by 2. IP address 172.16. 2 and 4, 24.1, 255.255.2, sorry, 2, 255.255.255.0, no shut. Ping 172.16, 24.2, myself 24.4. Okay, so save it. What about R3? Ping 172.16, 13.1 and ping 172.16, 34.4. That is 3 and 4 is also connected. Good. Show IP INT brief. Ping 172.16, 24.1 no, 2 and 4, 24, and 172.16.34.3, that is R3. So you see internal communication, WAN connectivity between R1, R2, R1 and R3 and R2, all is perfect. Now we'll be running EIGRP here on R1 and advertising my LAN as well as WAN. So I'll say router EIGRP 10 network. First we'll advertise the WAN. Network network so when I say show run pipe section router, I go to R2, say config T router EIGRP 10, advertise this with the network command. 12 and 24. So as soon as I get this, you see neighborship is up. And definitely 192.168.20.0. Go to R3, router EIGRP 10, network 172.16.13.0, 34.0, and network 192.168.30.0. So IP EIGRP neighbor, that is R1. Okay. So all the routers should have two neighbors. R1 is neighbor to R3 and R2. R2 is neighbor to R4 and R2 is neighbor to R4 and R1. R3 is neighbor to R4 and R. Okay. So R4. So now all the neighborships, so all should receive see R1 receive 20, 30, 40. 10, 30, 40. Ten, 20, 40. 10, 20, 30. So all of them can ping. Let's check. Can I ping 192.168.20.2 source 192.168.10.2 or 10.1? So we need to check the PCs. IP and gateway. Now let's see if he's going gateway. He should also go to 40.2 pinging successfully. He should go to 30.2. He should go to 20.2. Okay. Now, if you see in this scenario, we have not done any authentication. So if I add any network, it will be immediately exchanged between the neighbors. So what I'll do, I will go and do authentication, plain text authentication, but in simple password authentication. Okay. Or we can go for MD5. So which one is more powerful? As per this thing, MD5 is more powerful. So we'll go for MD5 authentication. Okay. Because I think EIGRP support only MD5 authentication. So we'll make a keychain, key ID, and then we can go and apply that keychain and key ID. So what is the command to make a keychain? Keychain, suppose say R1, key ID 1, and then the word is what? Key string. I said Cisco. Then I'll do is what? I will put key string Cisco, and then I will say Disco. So I created how many IDs? 3 IDs. Key ID 1 will carry a key string password Cisco, Kisco, and Disco. Now I go on interface, which is facing R2, that is E0 by 1, and say IP authentication keychain, or first we select the mode. Mode EIGRP 10, EIGRP 10, MD5, and then I say IP authentication keychain. See, the neighborship became down. Immediately R2 neighborship down because I enabled authentication. Keychain name EIGRP 10, and the keychain name is R. Start motion. Now remember, this keychain has to be exactly same to same on R2. And then we'll go to E0 by 1, which is facing R1. and say IP authentication mode EIGRP 10 MD5 IP authentication key chain EIGRP 10 R. Suppose if I am doing the copy paste same, then it will be R. Or you can make your own keychain R2. But I just copy paste. No? Now you see neighborship is on. So now R1 has become once again neighbor to R2. But this time, if you see how to see debug IP EIGRP authentication. Or you can say debug IP EIGRP. So suppose I create a loopback and add one IP address. Or when I just bring this interface shut and then I say no shut. So what I'll do, I will change the password or I will change the key ID. Okay. So I make a keychain R1 which is applied. Key ID I kept it 1, but key string I said this one. See? Down. Debug IP EIGRP neighbor. Ignored packet. Key ID 1 authentication mismatch. Can you see here? So now when I create any loopback, suppose I remove this loopback or I create one more loopback. It will not be propagated to this guy. And when I say show IP EIGRP neighbor, I can see only one neighbor. Clear? So when you do MD5 authentication, you have to match the key ID. So once again, I will go here, key ID 1, and then I say key string Cisco. And now you see, they have become neighbor and working fine. And when I advertise this network in router EIGRP 10, network 2.2.2.0 and network 1.1. They'll be exchanged. Always undebugged. one network and two network via 12.1. Clear? So this was authentication, MD5 authentication related to EIGRP. Okay. There are two commands. You can debug EIGRP packets and you can find out. I'm not using, see, basically, good question. They said why I'm not using keychain, three keychains. I'm using only one keychain, but I'm using three key IDs, key ID 1, key ID 2, key ID 3. Now you must be wondering why I did three when I can manage it with one also. Yes, you can manage your authentication with one key ID and one key string also. Okay. So the thing is, like, always you see the banks and all the other, institution always asks you to change your password often. Okay, they request you to change your password often. Don't keep for more than 1 month or two. In fact, my banking portal always, expire my password, transaction password, and he always tell me to create a new password. Now the thing is, why they do this? Because they want more security. So if I set a lifetime for key ID 1, what will happen? That key ID 1 and the key string that you created, Cisco, will get expire after some time. Say after 1 month or after 1 year, whatever. Or after 1 week. Depends what you have given, accept lifetime and extend lifetime. And immediately key ID 2 will start getting match between the two. So see, suppose if the hacker try to hack key ID 1, okay, he just must have about to use that key ID and the key ID get expired. And what key started? Key ID 2 started with a new key string. And the time he takes to crack that key ID 2 also with that key string, that also expires. So always he has to, keep on changing, keep on finding it out. So it becomes very difficult. No, I am trying to find out because I know you're not going to change your password for 1 year. Password. But if you change your password every week, it is very difficult for me to. You must have seen some movies, English movies or something like that. So they, in order to break that safe, you have to give some password, and the password expires every day. And every day a new password comes in. So the heroes, hero of that movie or the villain of that movie always plan it out how to bring that password, because every day it is going to change. So it is very difficult to crack the password. So the catch is, like, if you create multiple key IDs with multiple key string, they will expire at one particular moment, and immediately the next one will start processing. So if you specify the lifetime, it won't go beyond that particular time. Clear? So this is best practice. Or you can manage it with one key ID also. As a part of this, if you say show run, it will show. Showing, in fact. No? Okay. But then when you say service password encryption, it's gone. Veneer type 7 is the algorithm which hash this password. Veneer type 7. That is why it is written 7 here. And when you do enable secret, it is MD5 that hash the password. So your question is valid. Why we are creating more key IDs? Because we want every time, or if you are not setting the lifetime, definitely key ID 1 will be taken into consideration. But for some reason, anything happens, every key ID should match with the key string. You cannot have Cisco in key ID 3 and on the opposite side. Both the routers should have the same key ID and same key string. Both the routers should have what? Same key ID and same string, key string. So I hope this was all about MD5 authentication on EIGRP. Now we'll see it of OSPF. In OSPF also it supports authentication. OSPF also support authentication. OSPF support two types of authentication: simple password or plain text authentication and MD5. Though it was given in EIGRP also, but EIGRP support only one type of authentication, that is MD5. And definitely MD5 is more powerful. So in simple password, no, you have to set the expiry on both the router at the same time. No, how the other router will come to know? You have to do it on both the routers. Suppose you are asking me when is lecture, when will be the lecture next tomorrow. So if I am telling you the time, it is between you and me, na? How others will come to know. So you should know the time, I should know the time. So if I am putting an expiry of key ID on R1, I have to use the same expiry on R2 also. Other router will not come to know. You have to tell him manually, man. Otherwise, he will break the neighborship after that time period. Because see, this guy is suppose today is the pass. Today we have a password Cisco, so I'm expecting Cisco. But again, if you use the same password Cisco, I'm not going to accept it because my lifetime of this password is 1 day. So tomorrow I'm going to accept Disco, not Cisco. And if you don't give me that password, then I'm going to break the neighborship and won't exchange any network with you. Clear? Now, simple password authentication in OSPF. For that, we have to do OSPF on all the routers. So what we'll do, we'll just go and say no router EIGRP 10 and say router OSPF 1 network to show IP identity. Say network 172.12.0 India and 30 and 192.168.10.0 India. Go to router 2. The IP OSP of neighbor. Router OSP of 1. Network 172.16. 13.0. Area 0. 34.0. And 192. 30. No router EHR 10. Router EHR, sorry, router OSP of 1. Network area 0. One, okay, 24. So 24, 34, and 40. 30. So when I say show IP OSP of neighbor, so you see every router is having two neighbors. Okay. So IP route OSP of 20, 30, 40. So IP route 10, 30, 40. So IP route 10, 20, 40. 10, 20, 30. So OSPF is working fine. Now we are going to do what? Authentication. So if I'm doing simple password authentication, what is the command? Simple. IPOSP authentication, IPOSP authentication key on the internet. So we'll do this now between R2 and R4. So if I say show IP INT brief, I go to interface E0 by 2 and say IP authentication. Mode. No. IPOSP authentication. IPOSP authentication key and simple key. neighborship will go down when you say clear IP OSPF process, or at the next hello, they'll they'll do they'll down the neighborship because of authentication. Debug OSPF say down. So I will go here and say in the interface which is facing R2, interface E0/2, IP authentication, if it come up, you have to wait for the next hello. You see, the loading is done and it is full. So R2 and R4 have now become what? Neighbor. So R2 and R4 neighbor, and they are exchanging the networks. You see, you got 40 and this guy also got 20. So in plain text authentication or simple password authentication, you have two lines: IP/OSPF authentication, IP/OSPF authentication -key and password. But suppose you want to go for MD5, then it is IP/OSPF authentication message digest key MD5 and then the command. How to do that? We'll do between R1 and R2. IP/OSPF authentication message digest. IP/OSPF authentication message digest IP/OSPF authentication, message digest key 1. But I created message digest. Okay. You can create same what I did. Okay. Or you can directly mention the key ID and then the MD5. Okay. So the command is IP/OSPF authentication message digest key ID MD5 Cisco. So when I say show run interface E0/1, I can see two commands. Now I go to R2 and then say interface. It's always between two routers, not between R1 and all the routers. It is always on the WAN link, the connectivity. IP/OSPF authentication message digest. IP/OSPF message digest key ID1 MD5 system. Membership is up. So here we saw how OSPF MD5, how simple password OSPF MD5 authentication take place. Always remember, it can be done between R1 and R2, between R1 and R3, between 2 and 4. It is your choice. If you want to activate on all the neighbors link, then you have to do it on all the internet. It's up to you, but it is best practice. No, if you're doing it with one neighbor, do it with other neighbor also, so that attacker router may not take the advantage and try to find out the networks or exchange the networks. And for that reason, you do what? Authentication. So this was PIGRP authentication, MD5, and then OSPF simple text and message digest, that is MD5 authentication. I have given you the book. Okay. You can refer the book also. In that, it is given. Routing protocol. Yesterday, I think I opened it. One minute. Huh? See this. So we'll be doing VPN. Now we'll be starting VPN between two routers, between two firewalls, and we'll be doing side-to-side remote VPN. Then we have introduction to FTD, FMC, FTD, ICE. Okay. Again, whole April will go away in this. Clear with routing protocol authentication, guys? So today I won't be doing much. We'll start with VPN section from Monday. Tomorrow we don't have lecture. And that topic is very interesting because we'll be doing all theory as well as practical in VPN. Interesting topic. We'll do side-to-side VPN between two routers, side-to-side between two firewalls. We'll do get VPN. We'll do DM VPN. We'll do VPN with virtual tunnel interface, Flex VPN. There are a lot of VPNs. So don't miss Monday's session because there will be a theory. Okay. Just because I'm starting with the new topics today, I have to end this. but I showed you practical of EIGRP authentication MD5 and OSPF simple password authentication and MD5 authentication. Okay. Thank you very much. Take care. Bye. Happy weekend.